Hi, Amit Sharma. Welcome you all to my channel, Mathematical Coaching Center. So today's class will do Determinant Part 2. Those who haven't gone through with my Part 1, the link is given in the description. By the end of this video, you'll learn 5 very important properties of determinants. So let's start today's class. So in this class, we'll discuss about the properties of determinant. So number 1, we have the value of a determinant remains unaltered by changing its row into column and column into row. So I'll show you by an example. So example is, let d is equal to 1, 2, minus 1, 2, minus 1, 3, 3, 2, 3. So what this property says, if I'll change this row into column, the value will remain same. I'll show you this by expanding this. So as you already know that I'll expand from this row. So 1. So 1 means I'll hide this and this. So what I'll get? Minus 1, 3, 2, 3. So minus 1, 2, 3, 2, 3. Now 2. This is plus. This is your minus. So minus 2. Now I'll hide this and this. So what I'll get? 2, 3, 3, 3 is 2, 3, 3, 3. Now this side is plus. So I have minus 1. So now what I'll hide? The first row and the third column this way. So what I see? 2 minus 1, 3, 2. 2 minus 1, 3, 2. Now we'll expand this. So 1, this into this. So minus 3, this minus 2 3s are 6. Minus 2, 2 3s are 6. Minus 3 3s are 9. Plus minus minus. So minus 1. So 2 2s are 4. Minus is plus. So 3 1s are 3. Now 1 minus 9 minus 2, 6 minus 3 is your minus 3, minus 1, 4 plus 3 is your 7. So what I got? Minus 9 minus plus 2 3s are 6 and minus 7. So this I got minus 3 and minus 7. So I got minus 10. So in my next, what I'll do is that I'll change the row into column. So let's d dash. I'll take it as d dash. Now you can see 1 2 minus 1 is there. So I'm changing 1 2 minus 1 this way. So row has been changed as a column. So here 2 minus 1 3. So 2 minus 1 3. Here 3 2 3. So 3 2 3. I have changed into column. So now you have been perfect, I think so, to expand this. So I'll open from row only. For me it's because I have practiced from earlier to open from the row. So it's easy for me. So 1. So minus 1 2 3 3. This obviously you know minus 2. So hide this and this. So what you'll see? 2 2 minus 1 3. So 2 2 minus 1 3. So this 3, this and this you have to hide. What do you get? 2 minus 1 minus 1 3. 2 minus 1 minus 1 3. Now I'll open this one. So this into this minus this into this. So here this into this minus this into this. So this side this into this minus this into this. 2 3s are 6. Minus is plus. Plus into minus is minus. So 1. So here 1 minus plus 3 plus 6 is your 9. Minus 2 6 plus 2 8. 3 6 minus 1 5. So minus 9 2 8s are 16 and 5 3s are 15. So minus is plus. 25 plus 15. So minus plus is your minus. 25 minus 15. You can see here minus 10. So in this also I got minus 10. This also I got minus 10. So this property says if you change row to column or column to row, the value will remain unaltered. The value will remain unaltered. Now we have second properties. So property number 2. So what it says is that now you can see here, if two adjacent row or column of a determinant are interchanged. So you are changing rows. This suppose second row and the third row you are interchanging the place. What happens is that the numerical value of the determinant remains the same, but its sign is unaltered. When suppose I got the determinant 10. But if I'll interchange the value, interchange the row or column, I'll get, suppose I got 10, means this side I'll get minus 10. So the sign only will change. Let's prove this determinant also by an example. So d 1 2 3 4 5 6 and 3 2 2. So I have taken this example. So now I hope so now you have been perfect with the expansion. Yeah. So now expansion, so simple. I'll open from 1. So 5 6 2 2 minus 2. What happened? This side 4 6 3 2 and 3. So what happened? 3 4 5 3 2. So 4 5 3 2. So now 5 2s are 10 minus 12. So 4 2s are 8, 8 and 3 minus 3 6 are 18. 4 2s are 8 and 5 3s are 15. So this I'll get minus 2, this I'll get minus 10, this I'll get minus 7. So minus 2 minus minus plus 10 2 10s are 8 2 10s are 20 plus 3 7s are 21. So this and this 18 minus 21, so I got minus 3. So what I'll do now, I'll change any two rows or any column. So you can see I have taken D dash. So what I have done in this, you can see this, what I mean is I have changed this. This has been this. That means C1 and the C2 has been interchanged. So what I have done, interchanging C1 and C2. That means this C2 has become C1 and C1 has become C2. So similarly I'll expand this also. So I'll expand from this to hide this. So 4 6 3 2. So similarly this is the second is minus 1. So this 5 6 2 2. So similarly 3. So I'll hide this. So 5 4 2 3 5 4 2 3. So similarly expand 4 2s are 8, 3 6 are 18 minus 1, 5 2s are 10, 2 6 are 12, 5 3s are 15 minus 4 2s are 8. So what I'll get, 2 minus 10 minus 1 minus 2, 15 minus 8 is 7. So here 2 10s are 20 minus minus plus 2, 3 7s are 21. So I'll get here minus 18 and this side is 21. So what I got, plus 3. So can you see here, in previous we got minus 3, now we got plus 3. So the property says if I'll change any two rows or any column, two adjacent. Okay, so if I'll change any two rows or any two column, so what happens is that the sign gets altered. Means suppose if I'll get this side, what happens is that suppose I got plus 10 this side. So what will be this side answer? I'll get minus 10. Okay. Now I have property 3. So what does this property 3 say? So now so you can see if two rows or two columns of a determinant are identical. Identical means same. Identical means same. Of suppose two rows and two columns are same, directly I can write the value of determinant is 0. This is very important. Many times they ask in exam this type of question. Without expansion you have to prove 0. So let's prove by giving an example. You can see here, so date of A equals to 5 5 3 7 7 4 and 9 9 5. So what you can see here is that C1 equals to C2. They are identical. So by this property directly I can write 0. So no need to prove, but I'll show you in this proving. Okay, so you can see here 5. So I'll hide this. So what I'll get, 7 4 9 5. So now I think so you have been perfect. So minus 5. So this and this you will hide. So 3 7 4 9 5 7 4 9 5. This is your plus 3. This and this you will hide. What I'll get, 7 7 9 9 7 7 9 9. So now expand. So 7 5s are 35. 9 4s are 36 minus. So minus 5 7 5s are 35 minus 9 into 4 36. 7 9s are 63 and 9 7s are 63. Okay, so this minus this is minus 1. So 35, this is also minus 1. So 63 minus 63 is your 0. So 3 into 0 is your 0. So minus 5 plus 5. So I got, how much I got? I got 0. So okay, so this is your third property. So if the two rows or two columns, so in this the two columns are identical. Okay, if the two rows are also identical, then also the value will be 0. So now we'll do property number 4. So what does this property number 4 says is that you can see if each element of a row or a column of a determinant be multiplied by the same quantity. If it is multiplied by the same quantity, then the determinant is also multiplied by that quantity. So what does that mean is that I'll show you with an example. Suppose I have a date of A 2 1 3 5 4 6 2 3 2 equals to 3. So already I have proved this. You can do yourself. You will get 3. So in my previous sum, my previous property, I have proved this is a 3. Now what it's saying is that if I'll multiply the determinant, any row or any column, suppose I have multiplied by, you can see here, I have multiplied by 2. So 2 into R2 means R2 I have multiplied by 2. So you can see 2 5s are 10, 2 4s are 8, 2 6s are 12. That means directly by this property I can write this as 2 into 3. 2 into 3, what I'll get? 6. Directly by this property, the value also will get multiplied. The value, the determinant is also multiplied by that quantity. Okay, so I'll prove this. Now you can see here, so 2, I'll open from this 2. So 8 12 3 2. So minus 1 this side, so this 10 12 2 2 10 12 2 2, so this is your plus 3. I'll hide this, so 10 8 2 3. So what I'll open this, 2 8 2 is 16, 3 12 is 36, minus 1 10 2 is 20, 2 into 12 24, 3 10 3 is 30, 2 8 is 16. So now I got minus 20, so this minus this is your how much, minus 4, and 30 minus 16 is your 14. So now I'll multiply 40, so minus 1 is plus 4, 3 into 14 42, so minus 36 plus 42. So what I'll get, I got the 6. So already I said you, by using this property we can use directly this. So directly you can multiply that. Whatever you are multiplying, you have to multiply either row either column. Okay, you can't multiply whole thing. If you will multiply, suppose if you are multiplying the row, r1 also 2, r2 also 2, r3 also 2, 2 2 2, that means you have to multiply this value also 2 into 2 into 2 into 3. So how much? 2 2s are 4, 4 2s are 8, 8 3s are 24. So you will get this way. Okay, so it has to be each element of the rows and the column, and it has to be multiplied each and every rows, or if you multiply the column also, you'll get the same value. Now last property of the determinant, so 5. So the value of determinant remains unaltered if each element of the row or column is increased or decreased by a constant multiple of the corresponding element of the another row. So this is one of the very important properties. So what happens is that, let's do an example. So let d is equal to, I have taken, so you know d is equal to 1 2 minus 1 2 minus 1 3 3 2 3. So what I have got is minus 10. You can expand yourself and you can see, or you can see my previous video, I have got this minus 10. So now by this property, if you'll increase or decrease by multiplying or by adding, okay, the value will not change. So now see, you can see here, what I'll do is that in this, what I have done, C1 dash means I am changing this first column. So what I have done is that this plus 2 into this, you can see this plus 2 into this, so 1 2 3 as it is. Now what I am doing in the C2, I am multiplying by 2, so 2 2s are 2 into 2, 2 into minus 1, 2 into 2, and this second column and the third column I'll write as it is, 2 minus 1 2 minus 1 3 3. Now what happened in this is that you can see 1 2 2s are 4, 4 plus 1 is your 5, so plus minus is minus, so 2 minus 2 is your 0, 3 plus 4 is your 7. So this column 2 and column 3 as it is. Now on the third step, you have to write this way only at the side. What operation you are doing, you have to symbolize this way. Now what I am doing in this, r1 dash means r1 is changing. What I am doing to the r1 is that r1 minus r3, that means this minus this corresponding element I have to minus. So you can see in the next side, what I have to do, corresponding element I have to minus, that means 5 minus 7, so 5 minus 7. Now 2 minus 2, 2 minus 2, minus 3 minus 1 minus 3. Hope so you got it. So r2 and r3 will be as it is. So whatever you are changing, r1 dash, that only will change. Now what I'll get, minus 2 0 minus 4 0 minus 1 3 7 2 3. Now what I'll do, I'll expand this from this side. Obviously I'll expand from r1, so minus 2, hide this, so what I'll get, minus 1 3 2 3, this side minus 0, so this, so how much, 0 3 7 3, and this is your minus 4, so this and this will go, so what I'll get, 0 minus 1 7 2, 0 minus 1 7 2. So I have done two operations, but also by this property the value should not be changed, so it should come minus 10 only. So minus 2, so this into this, minus 3 3 2s are 6, so this obviously 0, so no need to write in the bracket. So minus 4 0 plus this into this 0, minus minus plus 7, so 2 minus 9, this 0, no need to write, minus plus minus, so 4 7s are 28, so plus 18 and minus 18, how much I'll get, minus 10. So you can see, so this properties are very important. You have to know this property. So this is one of the very important, either you will increase or decrease. Whenever you note that this C1 should not be changed, this C1, if you are changing the C1 should not be multiplied. You are changing R1, so R1 should not be multiplied. Okay, so the other number, other rows or other column has to be multiplied. So there are many applications. So in my next video, so we'll do some of the application of the determinant, means we'll we'll solve some of the numerical problem.